Okay, so today we're going to look at what happens when we transform equations. So you might have looked at transforming a graph of an equation. We're just going to look at the basic level of transforming the actual equation. So let's take our first one, for example. We want to know what the function f of x looks like as an equation when it's translated 3 units upwards. So when we translate something 3 units upwards, we'll be looking at f of x plus a, where a is the 3 units. So we have the new function g of x is equal to f of x plus 3. So now we're going to input this function, this f of x up here, into our new equation where f of x is now. So we end up with 3x squared plus 2 plus 3. Then all we do is turn it into 3x squared plus 5, and that's our solution. So that is what our equation is going to look like if we translate it 3 units upwards. When we look at our second question here, find the equation of the resulting graph g of x when we take the function f of x equals 3x squared plus 2 and we translate it 3 units to the right. Now what happens when we do that is that we have to say that our f is going to be of x take 3. So our new function g of x is equal to f of x take 3, all in brackets. So what that means is we're going to take this function f of x, and wherever we see x in that function, we're going to replace it with x take 3. So 3 x take 3 squared plus 2. Then we are going to have, so we're going to need to expand this one here. So we have 3 x squared take 3x take 3x plus 9 plus 2. And then we collect that all together. 3x squared take 6x plus 9 plus 2, which is 11. So our new function is going to look like this one here. And that's just from translating it 3 units to the right. When we talk about dilating, so we're either squeezing it together or we are widening it. Let's look at what happens if we take the function f of x and we vertically dilate it with a scale factor of 3. So when we vertically dilate something, we have it in the form, or we have the scale factor of 3, which is represented generally by c, and that is represented like so. So 3 times by f of x. So our new graph g of x, or our new function g of x, is going to be equal to 3 times by this entire function. So all we're going to do here, 3 times by 3x squared plus 2, which is going to be 9x squared plus 6, and that is going to be our vertically dilated function. What that's going to do is it's going to stretch it in the vertical direction 3 times as much as it was originally. So think of it like you're holding the elastic band and we're pulling it both up and down depending on what is above and below the x-axis. Looking at our second one, this is the more difficult one. So we're looking at horizontal dilation. Now, if we have a scale factor of 1/3, that means that we have f of whatever the inverse of this number here is. So the inverse of 1/3 is 3. So we have f of 3x. So our new function here, g of x, is equal to f of 3x
Once again, we're just going to look for any x's in the function f and replace it with 3x. So first of all, we've got 3x squared plus 2. First thing we need to do is whatever's in the brackets is going to be raised to the power of 2. So we've got 3 times by 9x squared plus 2, ending up with 27x squared plus 2. What that is doing is that is going to be dilating it in the horizontal direction. And because we've got a scale factor of less than 1, it's actually going to be squeezing it inwards towards the y-axis. So we're basically taking both of our hands, grabbing the equation and squeezing it towards the middle of the axis. Finally, we're going to look at reflecting with the equation. So when we look at reflecting, let's see our first graph, which is f of x equals 3x squared plus 2, and we want to reflect it in the x-axis. So when we reflect it in the x-axis, we take negative f of x. So our new equation, g of x, is equal to negative f of x. So it's just going to be negative whatever this whole function is. So we go negative 3x squared plus 2, which equals negative 3x squared take 2. Fairly simple. So that is reflected in the x-axis, which means that whatever is going on in the upper half of the graph above the x-axis, we are just flipping that around about the x-axis. Looking at the equation for our reflection in the y-axis. So we've still got f of x, same one, reflecting it in the y-axis. In this case, we now change it slightly. We have f of negative x. So we've got g of x equal to f of negative x. Once again, we take our function f of x and we're just going to replace every x in there with negative x. So we've got 3 negative x squared plus 2, which is going to give us 3 negative x squared, which is just x squared, because negative x times negative x is going to be positive, plus 2. Now, a really interesting result here. See that we have actually got our reflected function in the y-axis is the same as our original function. The reason for that is that this is already symmetrical in the y-axis. So we've already got a function that is centered on the y-axis, and if we flip it around about the y-axis, it's just the same function. That is why we have the exact same one down here. So f of negative x equals f of x.